Hello everyone, I am going to explain chapter 2 from class 10th. We will start first from the Euclid's division lemma because chapter 2 is based on it. So it's the statement of Euclid's division lemma, that is, if a and b are two positive integers, then there exist two unique integers q and r such that. So this students, this Euclid's division lemma is not new for us. From very childhood onwards we are using it. It's actually the division. So if you will divide, just see here I divided here. If a divided by b, then q is the quotient and r is the remainder. So what these are, a is our dividend and b is our divisor and q is named as quotient and r is the remainder. So it's the division rule. What the division rule is? Dividend is equal to divisor multiplied by quotient plus remainder. And students, we all know that this remainder can't be more than this b. And it's one more thing, that it can't be negative also. It can be 0, 0, 1, 2, 3, 4, but it cannot be more than b. So the restriction for a, r, just understand here, where r is either equal or greater than 0. So it is named as r is greater than equal to 0 but less than b. So how to read it? R is greater than equal to 0 but less than 3 but less than b. So I hope this Euclid's division lemma is clear to you. So for any two numbers a and b, the quotient and remainder are going to be unique. Means if you will divide, unique means which cannot be repeated, which cannot be created again, which is alone. So if you will divide a by b, then always answer is going to be q and remainder always going to be r. So r and q are going to be unique here. So this is our Euclid's division lemma. Now the exercise is based on this lemma. So we'll start from exercise 2.1. We'll start from the first question. Question number first is, show that square of an odd positive integer is of the form 8q plus 1, where q is a positive integer. So here what we have to show, that square of odd positive integer. So if we do the square of any odd positive integer, then whatever answer will come, that answer we can write as 8q plus 1. That we have to prove. So I hope question is clear to you. First we have to take the square. First we have to take the positive odd integer and then we have to do the square of that, and whatever answer will come, that answer we can express in the form of 8q plus 1, where q is positive integer. So this we have to prove. So we will take the help of Euclid's division lemma. So in Euclid's division lemma, a and b are two integers. So first I wrote here, let a be any positive integer and b is equal to 4. Now here students, we have to select what is going to be b. That is our divisor we have to select. So since here 8 is there, so selection is very clear, should be very clear to you, because we have to bring it in the form of 8q plus 1. So we are going to find out what are the numbers which divides 8. So the numbers which divide 8 are 2 or 4. So from there you can take 2 as well as 4. Better to take 4, then you will get varieties of number. That's why. So I am repeating again why I selected here 4, because 8 is divisible by either 2 or by 4. So just take 4, because if we take 4, then we can get many choices for the remainder. That's why we are going to select here b equal to 4. Now we are going to use the Euclid's division lemma in this. So according to Euclid's division lemma, a is equal to 4q plus r. Now here r, because divisor is 4, so r is going to be greater than equal to 0 but less than 4. So what are the options for r? So r can be here 0, 1, 2 or 3. So now here in this equation, instead of r, 1 by 1 we are going to replace first 0, then 1, then 2 and then 3. So that will give us these options. So putting r, we get, when we substitute here 0, it is going to be only 4q. When we substitute here 4q plus 1. Then when we substitute here 2, it's going to be a is equal to 4q plus 2, like this. Now students, here this equation, this one, that is a is equal to 4q plus r, I explained here that when we divide a by 4, q is the quotient and r is the remainder. And here since r is the remainder, so it should be less than 4. Because we know the remainder not going to be more than divisor. If it is, then it's going to be wrong. The division is wrong. So I explained here, from this division I wrote here the division rule. Now student, I substituted the values of r, first 0, then 1, 2, 3, then I got these 4 options. Now from all 4 options, since in the question, just see the question, in question what we want? Odd positive integers. So we will select from these 4 numbers, we are going to select the positive odd integers. So is it positive? No, it's not positive because it is divisible by 2. So is it positive odd integer? Sorry, here I think I said positive. Is it odd integer? So it's not odd integer because it's divisible by 2. Now here again we have to check whether it's odd integer or even integer. So if we divide it by 2, this 4q is divisible but 1 is not divisible by 2. So it's not divisible by 2, so it is odd. In the same way here students, 4q is divisible by 2 as well as 2 is also divisible by 2. So both are divisible by 2, that's why it is even. Now here 3 is not divisible, so it is odd. So what are the odd numbers here? 4q plus 1 and 4q plus 3. Now why they are odd? Because they are not divisible by 2. First write down here. Now why we selected? Because in the question we have to prove for odd positive integers, that's why. Now after selecting the odd positive integer, in the question what they are demanding? Square of the odd positive integer. So we have to do the square. So first we are going to prove for both. First for 4q plus 1 and then for 4q plus 3. So we started by 4q plus 1. I had done the square both the sides. Here when we do the square, we are going to open the bracket, and to open the bracket we have to use the formula a square plus b square plus 2ab. So here a is 4q and b is 1. So what is in the formula? First term a square. A square means 4q square, that is 16q square. Then b square, that is 1 square. Then 2ab, that's why 2 multiplied by 4q, and here multiply will come students, multiply by 1. So when we will solve this, that will give us 16q square. 1 square is 1 and 4 into 4, 2 into 1 is 8q. Now since in the question, just see in the question what in what format we want? 8q plus 1. 8q plus 1. 1 is separate and 8q is there. That's why students, here after reaching to this step, what we want, according to that we are going to take common. Since plus 1 is alone, separate in the question also, that's why plus 1 will separate here. Now from these two terms, 8 we are going to take common. So when we take common, divide it. So 8 2 is 16 and 8 1 is 8. Now this complete term just assume as m. Now this m you just replace again here, that will give you 8m plus 1. So again I am repeating, after taking common 8, whatever you are remain with the bracket, that complete bracket just assume as m. Now this 2q square plus q will be assumed as m. So in this equation, instead of this, replace it by m. So that will give you 8m plus 1. So we obtain square of all positive integer is 8m plus 1. But since in question it is in the form of q, so m you just replace by q. That will give you 8q plus 1. Now we'll start now the second term or positive integer which we obtained, that is 8q plus 4q plus 3. We have to do the square. So again just do the square by the formula a square plus b square plus 2ab, that is a plus b whole square formula. In that just put the values. Now after that you find that here you are getting 9, but in the question we want only 1. That's why this 9 you just split in the form of 8 plus 1. Now students, I am repeating here again, just see here. Here when we had opened the bracket, we got here 1. And in the question also 1 they want. That's why we had not done any changes here. But here instead of 1 we are getting here 9. But in question we want 1. So from this 9, 1 you just take out, then what remains? 8. So 9 we are splitted as 8 plus 1. Now from these 3 terms, take 8 common. So common means you have to divide. So 8 2 is 16, 8 3 is 24, then 8 1 is 8. Now this complete bracket just assume as m. Now in this complete bracket replace it by m, and m again replaced by q. So we obtained that square of positive odd integer again came in the form of 8q plus 1. So from the questions line just write down again and then write down hence true. So I hope this question number first is clear to you. So in this what we have to do? We have to prove that square of any positive odd integer we can write in the form of 8q plus 1. So for it students, you have to use the Euclid division lemma, that is a is equal to bq plus r, and here b is the divisor which you yourself have to select by your own choice. So whatever in question you want, according to that you have to select. Thank you.